I'm going to talk a little about like my own journey of understanding digital twins, perhaps, and what it is. And I mean, for me, digital twins is a fascinating topic. I mean, it's a way that you can transform data into something that you actually understand, some kind of story. And I mean, when you put data inside a 3D model of a city, for example, you provide a context. So, I mean, basically what you're trying to do is you take several components, and the result is more than the sum of the components, basically. I mean, it's a really powerful tool, and I think a lot of people realize this, and there's a lot of talk about it. But there's also like a long way to go until we actually know what we're going to use them, how we're going to use them, and so on. In sociology, a colleague of mine introduced me to the concept of practices, the way we do things over time, like washing more clothes and things like that. And then they talk about practices has like three components. It's the technology, but it's also the skills of using the technology and the images that kind of tells us why should we wash our clothes with a machine and how often do we do that and all those kind of things. And I think in digital twins we're in the same kind of place there. So we need to understand these more, and we need to develop the skills and the tools and all that. So we usually work a lot with municipalities and other organizations, and we do this kind of rapid prototypes. So most of the times the prototypes are kind of crappy, you know. We just want to get something quickly out there so they can start experiencing it and drive their own thoughts about how to use this further on. So a colleague of mine created a movie that I will show shortly, which is basically the same of this, but it's more like different stages of the development in a lot of different projects. And I'm just going to try to tell you or provide you the story I experience now from doing all those small prototypes. So, yeah. So this is the first project I'm going to show is a project I did together with Erika, which is here in the audience, and now changed to be working at the Stockholm municipality instead of RISE. But it was together with Stockholm municipality, and it was about the traffic situation in Stockholm and how it would change over time. And we had a team of KTH researchers and RISE researchers doing different models, but we also had like a lot of statistical data. So it's not maybe like an obvious digital twin project, but basically what it is like in Stockholm you have a lot of regions, and the smallest regions are the DESO areas, which is the smallest statistical areas you can have. And in this tool, we had this idea that, well, we have this Excel file, so now it's like into the vehicles Excel files, and it's the heavy vehicles in an area, and then you can switch it to another data set, and you all paint this kind of surfaces really quickly like this. So we want to support like basically three roles: someone putting all these Excel files together, someone exploring this data and finding the stories in the data, and then this bookmarking system would allow you to create a presentation so that you could present this data and use it in your daily work. And in this case, we show the weight of cars, and now you can see how it changes over time. So there's like a timeline which you can drag forth and back. So there's some like basic interaction concepts here that we were looking into. And at the same time, we were also looking into like, what if we go down one level and look into one area like Kista here, for example. And in this case, you see a lot of areas defined by Kista Limitless, which is interesting areas that will be developed. So instead of DESO areas, in this case, it's more like the real estate, fastigheten, or future real estates. And if you drag the timeline into the future, you can see like the new buildings popping up and so on. So this was something we've been really interesting in looking into how to do this, because most municipalities also, when they do this kind of 3D maps of a city, they always do the latest version and they throw away the old version. But in a true digital twin, you want both the old city and the new city, and you want to be able to transition into the future also. And in the future, you might have different scenarios. We're now going into Lucas projects here. So this is just something we did with them really quickly, like how would their stuff look in a digital twin like this, and they have different development areas, they have those waste bins, how would it look like, who will use it, and so on. So there's some kind of air quality sensor and so on. But from our perspective, the sustainability issues around the city is really important. So like one layer here, there's like a layer selector there, is the traffic. And right now it's just like a really stupid simulation of traffic. But of course, if you look onto those traffic cameras, we can easily put on some AI. I have some colleagues doing that to actually get some data so that traffic simulation can match different days of the times and different time of the year and so on. So we currently have like thesis student looking into that. This is we have other people at RISE working with stormwater management. This is just also something really stupid that we just stole from. I will show you the Gotland project later. It's about the rising sea level on Gotland, but we actually stole this and put it on Kista. Not because I think the ocean will come this high, but it's really good to find the low points with this tool. You can just drag it up and down and see where would water accumulate. And obviously, in the future, we want to implement our colleagues' really fancy models for this. This is a really old example of the electric grid. We did this for Urbanized Arena when they had like this yearly summit at Ericsson Studio a couple of years ago. And it was just like, the electric grid is a lot of secrecy around where it's actually based, but you can still, model it. We took some data from the Ellevio website and fed into to it to kind of show it. And here we're just showing that, well, if you would explore different alternative solutions with the consumption. So here's a third kind of level, going to the office. Now we're all returning back from the COVID. And I mean, at our place, the offices were really empty before the COVID. And when the COVID struck, they became completely empty. And now some people are returning, but mostly we have empty offices everywhere. So in this case, it's basically an internal project we have where we want to kind of find new key performance indicators. So like instead of talking about energy per square meter, we want to talk about energy per work hour or something like that. And we're also looking into the cost of different rooms and what if we could measure how many people are using this room and actually divide the cost on the number of work hours as well. So this is some early version of it. So right now we're implementing a lot of sensors to count the number of people entering and leaving, and also put in some sensor for the electricity meter. So we have the electricity for basically most areas in this. But also here we want to reuse like the thing we did with Stockholm City, like putting an Excel file on the rooms, and you can do the same here. You can drag forth and back in time. And this could be, for example, like temperature of the room, or it could be like how many people have been in those rooms. Are they occupied or not occupied? I mean, it could be all kind of things. And this, I think it's currently, now it's just area is not that really that interesting. This is the monthly cost, for example, for a room. And in the long run, I mean, we could divide the monthly cost also, as I said before, by the actual usage and get new kind of key performance indicators. What's something we're struggling with here is also like we have these separate sensors, and these sensors to be connected to those areas in some way, and we need to store data over time in a way. So, for example, if you have like a second resolution on the electricity, this is, by the way, when COVID struck, you can see the energy consumption going down. So we were really good at following the the guidelines. But all these kind of data, they derive from a certain sensor point in this room, but they don't do that much. There's not that much use of just seeing how many that's been passing in and out through this specific door during one day. We need to like summarize the number of people that are in a certain area. So when you do a histogram, for example, we could like put 4 buckets here, and all of you could turn one like ball into every bucket depending on some properties. For example, your age. If you're between 0 and 20 years, you would put in one bucket, and if you're between 20 and 40 and 40 and 60 and so on. And we will make a nice histogram. The same thing applies for this, only then it's like it might be like where people have been, which rooms people been in. So we kind of have these buckets all the time where we need to summarize over hours, over days, over whatever. So when we run the timeline and quickly move from one year to another, we can play up in a really high time-lapse speed and still see all the details of things occurring. The same goes for a piece of road, for example. If you start counting the cars there, you saw earlier when we did the speed up of time, you see the cars are moving really quickly. But if you speed up time fast enough, it's no point of having individual cars driving around. Then you need to replace those cars with lines instead. You know, those photographs you take during the night of cities when you have long exposure. Basically, you want it to look something like that, and the lines would become wider or more narrow depending on how much car that's been on the road. So, and this is another application example. This was done for Almedalen. It was just, we got some data from region of Gotland, and we actually had really high resolution data of the heights of the ground and those kind of ortho photos that they have. But we had to scale it down because this was supposed to be a quick prototype. We didn't have time to do all the things you need to do when you have a really heavy model. Usually you split it down into cubes, and then you have different level of details. And when you zoom in on things, you load higher resolution, and when you zoom out, there's lower resolution and so on. But basically, this was a tool for if you want to build something on Gotland. Some areas are restricted, you can't build there. Some areas, it's hard to get the permit there, but it's not impossible. And then there's other places where you can actually really easily get a building permit. So in this case, we had this kind of structure, which then we started off with their data and trying to organize it so that it would make sense for this kind of application, which was then driven by someone who wants to build a new house there. And this was the thing I was talking about earlier when we were stealing from this digital twin and putting on into Kista. This is basically just like, yeah, if you want to live close to the water, where are the big hazards? And the white area here is basically like supposed to be the difference between high water and low water. So, you know, it's not only that the sea levels will rise, we will also get more extreme climates and higher waves and all those kind of things. So even if the ocean doesn't reach your building on average, you might do when you have this kind of autumn storm or whatever. So this was, if you want to have you want to drill on Gotland, it's really like a difficult thing because they have salt water coming in on some kind of levels, you know, and if you drill through that, the salt water will go down into the sweet water. So some places it's really prohibited to drill for to have this kind of heating installation where you got geothermal heating. So this is just that. But yeah, so you can see there's a different structure here to the data and so on. And to summarize, like our findings with the data is like, if you want to sort data and structure data, it's pretty much like when you have all your files on your computer and you need to have a neat order for it. Sometimes you put everything in different projects, you know, and then in the projects folder, you have like a presentation folder. There you have all the PowerPoints. But then when you want something and you don't remember which project it was in, you have, you know, a really busy time finding that PowerPoint. The other way is to structure it so you have like a PowerPoint folder where you put all your PowerPoints, you know, regardless of project and so on. So there's always this like several different hierarchies that we can sort data into. And there's basically 3 of them which are really important for us. Like the first one is like just having a place to put stuff where the name of it doesn't get changed all the time. So for example, a building is usually denoted by its address, but sometimes it has two addresses. This is both Isafjordsgatan 22, is also Kistagången 16, and it probably has some more addresses. A real estate has a specific ID, for example, but a certain floor, for example, this floor is the ground floor, and there's a lot of building with ground floors. I can't have one folders with ground floors because it would be kind of impossible. So I need to connect them to the building they're in and so on. So those kind of namespaces is like, I just want some place where I can store the object. The other kind of hierarchies are the sensor processing hierarchies. So if we want to calculate the average temperature of this floor or this specific room, we need to know which temperature sensors are in this room, and then we summarize them and get the average, the maximum, the minimum, and so on. The third kind of hierarchy is a hierarchy which is very much connected to the application you're showing. Who is the user of this? And for example, in this case, we have scenes, we have layers, and one layer could be traffic, and then everything connected to traffic should be lighting up. In some cases, it's electricity, but if you think about a digital twin which is only about electricity, then it might be certain parts of the installation that is put into one layer and another into another layer. On top of this, the most difficult part, I think, is like capturing changes over time. So in this case, this room, I bet, has some time in the, I mean, if you go back, it was probably another room here. You know, they probably took away a room here to provide more space here after a while. So this is kind of a common thing. And in our office, there's a lot of rooms that have been changing. Walls have been knocked down. New walls have been built. The same thing for Kista now as it develops. Some kind of real estates get cut into two, some gets merged together and all that. So modeling scenarios and these kind of changes over time, I think is a great difficulty. And it's really like we wanted to get all the data from the energy declarations for buildings out, for example. And it's really hard to get historical data because most just store the just recent data. So when we get the APIs to Boverket, we could only get, you know, the most recent energy declarations and so on. So yeah, to conclude, I just think like Kista is a really nice test bed, and it would be really wonderful if we could get going some kind of activities around these digital twins here, and how to collaborate and yeah, share ideas.
Thank you so much. Thank you, Anton.